training number 2, end connections. Today we'll be discussing double end plates. Now, a double end plate is when a beam such as this needs to have an end plate on either side. That's a wee bit nice sizes. Should make that one smaller. Alright, so what I did here was set up a wee bit of variety. We've got a couple of different scenarios. So let's start with opening up the double end plate. It can be found here on page 1. Second connection, double-sided end plate 142. Now, to start off with, I'm going to put in the standard 2 clearance. I'm going to make sure both plates have a thickness of 10, and then we get to the bolts. M20 8.8 to tolerance. Okay, from top of beam, our first bolt will be 70 down. Now the amount of bolts, of course, is dependent on the beam that it goes into. Do 90 cross centers with 30 on a side, and before I do the rest, I'm going to put it one in so long. Now, as you can see here, this connection, well, doesn't want to put in. Normally when this happens, it gives you a small menu. Just cancel it, do a quick undo, and put it in again. So the first time round, the computer can't calculate everything as it should. The second time around, usually it will work. Good. Now, next, we are going to put in 70 for the distance from between the bolts, the standard 35s to the bottom and top of the plate. Now, before we get to the bolt mounts, as you can see, the notch is not exactly correct, so I'm just going to go in here and say I'm not in the mood to set up all of this. Normally you'd pick your choices, fill in the information. I'm just going to take one, load it, and I don't want any of the other information, only these ones. Modify. Excellent. Now the reason I don't use any of the other information is because, as you can see here, it does give length of the plate as well as the thickness. Unfortunately, all these plates have a thickness of 8, which we do not use. Okay, so now that I've done that, I'll just double click or say get to get all my settings again. Go back here and start working out according to 4.5. This is 5 bolts. I'm just going to pick one side, put in 5, see what it says. Does it for both sides. Put 4 on the other side. Okay, now I know which side's which, and I can just swap them around. Usually this is determined either by the order they put in or largest one first. In this case, easiest is just to do it and see what happens. Excellent. Now, I'm going to keep these settings for further use, and we can go on to something else, a bit of a different scenario. In a case like this, where you've got a channel on the one side, let's just see what size this is, 200. Okay. problem with plates that aren't exactly uniform. 2 on one side, 4 on the other. Unfortunately, even though this is a 4-5, it has to have 4 because the biggest member, or the small of the two members, is the main beam, and that's only a 4-6. Now, next, as you can see, it's other way around. So that's 2, that's 4. We have a wee problem with alignment. These bolts don't align. So I'm going to get a direct view from the top, show you again. Here's our problem. Now, something like this, it's quite easy to solve. What you'd want to do is get a measurement, usually from the edge of the plate or from center to center of the plate, and see what is the difference. Then if you go to plates 2, right here at the bottom, you can move one of the plates and thus align it with the other plate. As with most of these type of things, simply changing the plus and a minus will determine which way it goes. Okay. Now, if for example, let's just put the base one again, you've got 2 channels. The process is very similar to a one-sided end plate. Let's just put the amount of bolts right here. In that again, we need to align the plates. Actually, we need to disalign them. As I said, very similar to a single-sided plate. The setting you're going to use to get these into the correct position will be, of course, center of the plate to the back, and that measurement you will put in here. Excellent. If a positive amount doesn't work, go for the negative. It is usually a case of either or, as with most of these. Now, what I've done here is set up 2 beams that aren't aligned, both going into the same beam but at different points. From time to time you will get something in this line. Let's just open up the first one, get its settings. Put in the double-sided end plate and go look at the problem we got, which is they don't align. Now, standard procedure, same as channel. First thing you want to do is align these 2 plates. Now, normally the difference between these 2 plates will be the difference between the 2 beams. Quite easy to work out. If not, just measure. So in this case, this is going to be a minus. Right, now that the 2 of them has been aligned, secondly, we wish to use the middle of these 2 as our midpoint. So I'm just going to put a point, the 2 centers. Again, just a simple measurement. And that should give you the amount to the side. Now, as for our last problem, you can see that a standard cross centers no longer works. So, for something like this, you will simply take the standard cross centers, which is 90, and then add the difference between the 2 beams, 40 in this case. Give us 130. go. And this will give us from the center to the bolt 45. Okay, so fairly simple solutions to a variety of problems. As you can see, it goes off to the one side and one side, but that can unfortunately not be helped. Now, for our last one in this exercise, I'm going to show a double-sided end plate when bracings are involved. Same as before, put it in, find which one is bigger and smaller. In this case we've got a 305, 5 bolts, so that's this side, a 305, 3 bolts. That side we've got a 4-6, which is 4 bolts. This will give us something in this respect. Now, as you can see, this bolt is very close to the bottom here, 20, which is less than preferred. And normally, a case like this, you will need to cut out a small little haunch here at the bottom, something like just 40 back, just to make installation easier. Now that will be done with a simple poly beam. From there, take 40, cut it down, to give us that. This gives us a nice open area to allow for the fastening of this bolt. Another method, of course, if you've got the space for it, is to take a measurement between these two. If it happens to be more than 110, you can just move that bolt down in between them. In this case, it's not more than 110, therefore it's not possible. Okay, now, next up, I'm going to make some modifications to accommodate our two bracings. I'm just going to put a standard connection in here. I'm not really too worried about getting the connection right at the moment, as this is about the beam connection. Take out this completely. In a case like this, always remember, Tekla only does its clearance from the one side. You will need to increase that clearance until the other side's clearance is correct. This has to be between 16 and 20. It is really good. That will suffice. Let's try this side. I'm going to shape the bottom 138.6. It's not bad. It's not going to be a very nice number to use. So, minimum from there, from the bottom to the first bolt, it's going to be 55 plus the 35 to the bottom, which is 90. So that's less than 90. Yeah, 90 is less than the amount given. So let's change this to 70 plus 35, 105. Okay, that's going to be just a wee bit too short. So I'm going to say 55 plus 70 plus 35 gives us 160. That's a good value to work with. I'm going to make this 160. It's a little bit more than measured, but it falls nicely within a set of round numbers. Makes this a lot easier. Here at the top, I'm just going to leave it squared off. We'll just have to remember to miss this bolt completely. Now, as for these calculations, first off, getting the distance. Once you've got this distance, you've got the side with the 4 bolts, our bolt, first bolt, is not going to be 70 from the top, but 377 less 35. So 342 minus 342. So my first bolt's going to be up here. Now, as soon as I did this, the beam's haunch comes into play. Now, I don't want this haunch, so I'm just going to take these off. So just a single plate leaves it open for our gusset. Now, between our bolt and there is 342. Our bolt from here is going to be 70, so 342 less 70 is 272. It's not a bad distance. I will want to have a couple of bolts in between. These bolts are acceptable positions. Let's see, what's this distance? 130. Bad. Let's divide this by 70, get a rough estimate of 4 bolts. So we take this, we divide it by 4, that's 68. So first distance is 68. We'll have 1, 2, 3 of those. Let's see where that comes out. Let's make this just a couple of more. The exact value is not important at the moment. So 68. As you can see, the second one doesn't really add up. So let's make this 70. Increase this one to our maximum of 110 just to get rid of that. From there on, let's work out the difference between these two. It's 162, 962 less 70, it's 92. Okay, so 92. Going to be 140. The reason it's 140 is because it's 70 to there and then 70 to the next bolt. From there, we're going to have 1, 2, 3 at a distance of 70. Now, for our next distance, we'll have to take a measurement. We're going to measure the distance from there to the bottom, 117. Now 117 plus, we said 55, so 117 plus 55, 172. Next distance is 172, then after that 70 again. as you can see here, we've got quite a lot of different numbers. In the end, it does work out. We've got our 35 from the top, we've got our 70 from the bottom. These bolts are divided in to fit properly. Nothing is more than 110, nothing is less than 55. Acceptable values. Then we've got our standard 4 bolts at 70 each. After that, we've got a 55 from the bottom flange and a 70 with the 35 to the bottom of the plate. If you look here, this number is 54.7. It's not a round number. Tekla will round it down to the nearest 1 millimeter, which is 55. So that's not going to be a problem. If it does bother you though, it's very easy to fix. You'll simply need to add the 0.3 to this value, and that should give you a nice round number. Alright. I think that's it for double-sided connections.